The focus of this lesson is on finding the inverse of a rational function as well as determining the domain and range of the rational function and its inverse. And we're going to start off by rewriting our original equation so that instead of it saying f of x, it says y equals. And so it says y equals x minus 1 over x minus 3. And what we're going to do is we're going to interchange x and y because that is the key step for us being able to find an inverse. So where there's a y, we'll replace it with x, and where there's an x, we will replace it with y. And then what we do is in our third step is we have to solve for our new y. So notice that y is in two positions in the fraction or in the rational expression. So what we need to do is we need to get all our y's on one side in more in a linear fashion as opposed to in a rational expression. So what we're going to do is we're going to go ahead and cross multiply, because whenever you have two fractions or rational expressions that equal to each other, you can cross multiply. And so you would get x times y minus 3. And then the other diagonal is 1 times y minus 1, and those are set equal to each other, and you're going to go ahead and distribute. So this is xy minus 3x equals 1y minus 1. And then since the goal is to solve for y, you need to have all your y terms on one side of the equation. So I'm going to subtract off y to bring that term over, and then have all your other terms that do not have y on the other side. So I'm going to go ahead and add 3x to both sides to move that negative 3x over. And then what that allows us to do is on that left-hand side, every term has a y, so we can go ahead and factor that out as a greatest common factor. So basically divide it out, and that leaves us x minus 1. And to solve for that y, all we need to do now is divide off the factor x minus 1. What we do to one side, we do to the other. And so we can see that y is 3x minus 1 over x minus 1. And that new y that we just solved for is our inverse. So it's f inverse of x. So that's our last step. So that's like step 4. So we just rewrite it. Instead of y, we put in f inverse of x is 3x minus 1 over x minus 1. So we found the inverse. And then now what we need to do is we need to determine the domain and range of f and the domain and range of f inverse. So I need the domain of f, I need the range of f, I need the domain of f inverse, and I need the range of f inverse. Well, according to our little box here, we know that the domain of f is the same as the range of f inverse, and the domain of f inverse is the same as the range of f, so they should be equal at the end of the day. Well, the domain of f, well, if we look at our original function f, it says that x is not allowed to be 3. So that means the domain is everything but 3. So negative infinity to 3 but non-inclusive, union 3 to infinity. Well, the same would be true for the range of f inverse. And so that just means the y, because it's a range value, can't be 3. And so it'd be identical. So negative infinity to 3, union 3 to infinity. And that should kind of make sense, because right at the start when we swapped the x's and the y's, we could have put the comma here, and instead of writing x is not 3, we could have swapped that x with y, and it would have said y is not 3. And so we would see that the range can't be 3. And then if we want to determine the domain of f inverse, we have to look at our f inverse function, and we can see that x can't be 1. So it can be everything but 1. So negative infinity to 1, union 1 to infinity. And then the range of f would be the same as the domain of f inverse. So in that case, the y value, it can't be 1. So it could be negative infinity to 1, union 1 to infinity. And then you're done. So we found the inverse, and we found the domain and range of our original function and its inverse.